In our second IPv4 subnetting exercise, we are dealing with a Class B address space. Class B by default has 16 host bits and 16 network bits, indicated by the subnet mask of /16. And again, we need to borrow some of these host bits to make the networks. Nevertheless, we need to pay attention of the requirements for the locations. Network A, 4400 hosts. Network B, 3500 hosts. Network C, 1200 hosts. And the connection networks D, E, and F, which each require 2 hosts. So some of the host bits we cannot borrow. If we now apply the hosts formula, 2 raised to the power of number of bits remaining minus 2 gives us the number of hosts. So in order to accommodate 4400 hosts, we need 13 host bits. And if we subtract these 13 host bits from 32, we arrive at 19 network bits. Network B, we will need 12 host bits to accommodate 3500 hosts. And if we subtract the 12 from 32, we arrive at 20 network bits. Network C, we will need 11 host bits to accommodate 1200 hosts. If we subtract the 11 host bits from 32, we arrive at 21 host bits. The connection networks each only require 2 host bits, and therefore we will have 30 network bits for those networks. We now apply this to our task at hand, and network A, with 13 host bits, we will have 19 network bits, a subnet mask of /19. We know that bit 19 is in the 3rd byte and it is worth 32. In network B, we have 12 host bits, leaves us with 20 network bits. Bit number 20 is in the 3rd byte, but it's worth 16. Network C, 11 host bits with 21 network bits. /21 is the subnet mask. Bit number 21 is also in the 3rd byte, but it's only worth 8. And then for the connection networks, we will use 2 host bits, 30 network bits, /30, the subnet mask, bit 30, as in the previous exercise, is in the 4th byte and it's worth 4, and that's the same for network E and for network F. That leaves us with the following networks. Here are our location networks. Network A, we maintain the original network address of 168.45.10.0, but we change the mask to /19 as opposed to /16, indicating we're using 19 network bits. Bit 19 is worth 32, it's in the 3rd byte, so we know we have to add 32 to the 3rd byte to get to the next network. So therefore network B's network address is 168.45.42.0 with a subnet mask of /20. Here we use 20 network bits. Bit 20 is also in the 3rd byte, it's worth 16. So we know the next network we have to add 16 in the 3rd byte, which gives us a network address for network C of 168.45.58.0 /21. We know that bit 21 is in the 3rd byte, it's worth 8. So to get to the next network, we must add 8 to the 3rd byte, and that is our first connection network. It is at 168.45.66.0 with a mask of /30. Now we know that bit 30 is worth 4 in the 4th byte, so the next network we need to add 4 to the 4th byte, and therefore network E's address is 168.45.66.4 with a subnet mask of /30. And again, bit 30 is worth 4 in the 4th byte, so the next network we must again add 4 to the 4th byte, and so the last network address in our example is 168.45.66.8 /30. If we had to make another network, it would be at 168.45.66.12. Each of these networks has an enormous amount of unicast addresses. Network A over 8,000, network B over 4,000. Therefore, the first host is at 168.45.10.1. This is the first unicast address, but we need to increment or add to the third byte and the fourth byte. So we need to go up all the way to 31 in the third byte, all the way to 254 in the fourth byte, to arrive at the last unicast address of network A. And the last address of network A, 168.45.31.255, is of course the broadcast address. Similarly, here network B, again we have to increment or add to the third byte and the fourth byte. We see here third byte 168.45.42.1 is the first unicast address, but the last one is 168.45.57.254. So we see we increment the third byte and the fourth byte. And the last address for network B, of course, 168.45.57.255 is the broadcast address. Similarly, network C, here the last network bit we took is bit number 21. So this one can accommodate over 2000 hosts or unicast addresses. And we see we have to increment to the third byte. We go from 58 all the way up to 65. And we go increment the fourth byte from 1 to 254. The last address in network C, 168.45.65.255, is the broadcast address. Then the connection networks, we only have two hosts or two unicast addresses each, 168.45.66.1 and 168.45.66.2, and we only increment the fourth octet here, because remember the last bit we used was bit 30, which is worth 4 in the fourth byte. Therefore we do not increment the third byte any longer, just the fourth byte. The next network, 168.45.66.4, the first unicast address 168.45.66.5, the last one 168.45.66.6, only two. And the highest address, 168.45.66.7, is the broadcast address for network E. And the last network, network F, begins at 168.45.66.8, that's the network address. Again, we needed to add 4 to the fourth byte to arrive at this network address. And again, we only have two unicast addresses, 168.45.66.9 and 168.45.66.10. And the highest address in network F, 168.45.66.11, of course, is the broadcast address. If we had to add another network, it would be again, we would have to add 4 to the fourth byte, and so therefore that network would be at 168.45.66.12. The last step is to apply this to our network diagram. Network A, 168.45.10.0, all we did is change the subnet mask from /16 to /19. Bit 19 we know is worth 32 in the third byte, so therefore we added 32 to the third byte to get to network B. The network address is 168.45.42.0 with a subnet mask of /20. Bit 20 is worth 16 in the third byte, so now we add 16 to the third byte to get to network C's network address of 168.45.58.0 /21. Bit number 21 is in the third byte, it's worth 8, so we must add 8 to the third byte to get to network D's network address of 168.45.66.0. But now we change the subnet mask to /30. Bit 30 is in the fourth byte, so we must add 4 to the fourth byte to get to the next network address. So network E's network address is 168.45.66.4, subnet mask of /30, so we only increment the fourth byte. And we do that again for network F, since /30 tells us increment by 4 in the fourth byte, so therefore network F 168.45.66.8 /30, and this concludes our task at hand.